Hello everybody and welcome to another video in this Blockchain for Beginners tutorial series. In this video, we're going to be continuing from the last video and learning more about Solidity. Once we learn a few new topics, then we're actually going to work on an auction where we're going to be auctioning an NFT. Now this will work with any type of NFTs. This is really cool, and if you're interested in NFTs, you're going to learn a little bit about how they work. So with that said, we'll get into the content in a second, but I do need to thank Cartesi again for sponsoring this video and this series. They are an awesome company. They've been helping me come up with the content for this series, and they have a bunch of scaling solutions for Ethereum and for developing smart contracts that we're going to look at in a future video. Regardless, let's go ahead and get into the content. Alright, so I'm back in Remix, and in front of me I have the example that we finished in the last video, which is kind of a mock bank account. Now what I'm going to do is just give you a quick recap of everything that's in this contract so we understand the syntax and get a quick refresher. Then we'll look at some new Solidity features, and we'll actually move into working on that auction, which is going to be the bulk of the video. Okay, so right now we can see we're inside of a .sol file. Now the .sol stands for Solidity, and that's the extension you need for your Solidity smart contracts. Now at the top of our contracts, we need a pragma line. Now the pragma line is going to tell Solidity what compiler version we should use. So in this case, we're using 0.8.10. To see the compiler versions, you can go to the Solidity compiler extension, click here, and then it will show you the versions. In this case, 0.8.10 is one of the latest, so that's the one that we're going to use. Great, we then define our contract. We say contract my contract, open the curly brace and close the curly brace, and inside of here is the content of our contract. Now it's worth noting that you can define multiple contracts in one Solidity file, and you can have stuff like contract inheritance. That's a little bit complicated. We don't need to look at that here, but just wanted to mention that. Okay, so inside of our contract here, we start by defining what most of you would consider a class attribute. This is just going to be actually a private member of this class because we've defined it as private. Anyways, this is a mapping type. Now the mapping type is like a hash table or a dictionary where we have some key that can be associated with some value. Now in this case, we're having an address. This is going to be an Ethereum address being associated with a uint, so an unsigned integer. We then denote this as private, meaning we can't directly access this from outside of the contract. And then we have balances. That's just the name of this mapping. Okay, now we have a function. The function is called deposit. It's denoted external and payable. Now, external says that we can only call this function from outside of the contract. So I couldn't go here and do something like deposit. That would be invalid because this is an external function. Then we have payable. Payable is saying that this is either going to be sending money to someone or receiving money, or specifically Ether. And in this case, since we're going to be getting money, we have to make it payable. Then what we do inside of deposit is we say balances at message.sender. Now message.sender is going to be the address of the sender of the transaction who's sending money to this contract. So essentially whoever invoked the call to this contract or made the transaction to this contract, it's going to be their address. We're adding that as a key to balances, and then we're going to increment the value here by message.value. Now, message.value is going to store the amount of Ether that they sent to this contract. And the reason why we can do this is because the default value of all of our uints inside of our mappings is going to be 0. So even if this sender does not already exist in the mapping, we'll simply make the value equal to whatever the message.value is because the default value is 0. Hopefully that makes sense. That's explained in the previous video in case you are confused. Regardless, we now have withdraw. So withdraw is going to take in an address payable. This is going to be our ADDR. That's going to take in uint amount. Now, this means that we need to pass an address to this withdraw function. This is the address that we want to withdraw funds to. Then we have uint amount. This is the amount of funds that we want to withdraw from the contract. Now, this is a public payable function. When we say this is public, that pretty much means it can be called from anywhere. And then we have payable. And again, what payable means is we're either going to be sending money out or receiving money. So of course, we need to denote this function as payable. Okay, we then have a require statement. Now what the require statement is going to do is it's going to check if this condition is true. And if it is not true, then it's actually going to raise an exception. And the exception is going to be insufficient funds. That means we're actually going to cancel the entire contract call. Everything that would have happened is going to be reverted. I'm going to talk about this more in a second. And essentially this transaction is going to fail because this condition was not satisfied, okay? So you use require when you want to ensure that something is true before proceeding in the contract. Okay, so we're requiring that the balance of the address is greater than or equal to the amount that we want to withdraw. Makes sense. If we don't have that, then the error or the exception is insufficient funds. So next, we're actually going to send money from the smart contract to this address if they had sufficient funds to withdraw. So we're going to say bool sent bytes memory data is equal to addr.call, and then we're putting the amount that we want to withdraw, and then we're actually calling this transaction. Now, if you're confused on how this line works, I spent about 3 or 4 minutes explaining it in the last video, so you can go back and watch that. Essentially, all this is doing is sending money to this address. This is the amount of money that it's going to be sending, or the amount of ether. Great. Then we have this bool sent. Now this bool sent is going to be equal to true if we successfully sent this. Otherwise, it's going to be equal to false. So if we were not able to successfully send the money, some error occurred there, then we're just going to raise the exception could not withdraw. Otherwise, what we're going to do is we're going to update the balances. So we're going to say balances at message.sender minus equals the amount to make sure they can't just keep withdrawing the same amount of money. It's actually going to subtract from their current balance when they withdraw. Great. Then we go to this function. So this is get balance. Now let's say public view function. Now again, public means we can call this from anywhere, and view actually means that this is only going to be returning or accessing state from this contract. It's not going to be modifying it. So this means we can call this get balance function without actually having to make a transaction, which pretty much means this is free to call. So this is a good point in time to remind you that whenever we're just accessing the state of a contract, this is free. We can just query the state of the contract. We don't need to pay for this. However, if we're going to be actually modifying the state, then that requires a transaction. That transaction needs to be mined. And well, that means it's going to cost us some money, at least in gas and potentially Ethereum, if what we're doing requires that we send Ethereum. Okay, so let's continue explaining this. We then have returns and then uint. Now returns is just stating what this function is going to return. We're saying uint, standing for unsigned integer. And then here, all we're doing is we're returning the address of this. Now this is just going to be the contract. We're just going to cast this to its actual address. And then we're going to get the balance. Whenever you have an address, you can access the balance by just using .balance. There you go. That is everything that we did inside of this contract. So now that we've talked about all of this, I just want to spend a second talking about exceptions because we've seen them in this contract, but I haven't actually talked about exactly what they do and how they work. So in Solidity, we have a few different ways to actually throw an exception or to cause an exception to occur. Now, an exception is pretty much an error that's going to occur in our program, and all exceptions in Solidity are state reverting. Now, what that means is if there's ever an exception at any point in time during the transaction call, then this is going to revert the state back to what it was previously. Any changes you've made up until that point will be completely removed. So just to give you an example here, let's say that I did something like balances at 1 is equal to 2. Now, I know this makes no sense, but let's say I did this right here. And then I come to this require line, and this actually ends up raising an exception because sent is equal to false. Well, if that's the case, this line will be completely reverted. We won't actually have done that operation. It will be undone and reverted back to what it was before. So just worth noting, whenever an exception occurs, any of the state in the contract that's been changed is going to be reverted. Now, require, as I'm kind of alluding to here, does cause an exception, right? So if the condition here is not true, then it raises an exception, and the message for that exception is going to be whatever we put here. Now, there's a few other ways that we can raise exceptions in Solidity. I'll quickly show them to you, although we're not really going to look at an example of them. So one way to raise an exception is to use revert. Now, revert actually allows us to just directly revert the entire contract state. Again, this is just going to raise an exception exactly like require will, except inside of here, we can just put our error message. We don't actually need to put any condition. So if we ever encounter a revert in the program, we're just immediately going to raise an exception. The exception message will be this. And again, that's going to revert the state because that's what all exceptions do in Solidity. Okay, so that's revert. Now, another thing that we have is assert. Now, assert is similar to require. In fact, it works in the exact same way, except it's designed to be used when you want to check invariance rather than checking input validation. So I'll show you here. I could do something like assert true is equal to true. Now, of course, that's always going to be true, but you get the idea. Now, if this condition was false, what would happen is we would raise an exception with this as the error message. Now, assert and require are pretty much identical, but the reason you use assert is because you're checking an invariant. If you don't know what that means, don't worry about it. And if we're using require, we're using that when we want to check input validation, okay? So that's why we're using require here, because we want to ensure that the amount that they passed in is valid. Now, in this case, we could probably actually replace this require with an assert. It's not a huge deal, and there's actually not really any formal recommendation on which one you should use, but it's kind of the standard to just use assert when you're checking an invariant and require when you're checking input validation. So in this case, based on what I'm saying, we would use assert here because this is an invariant, but we also can just use require like I had before. That's completely fine. Anyways, this isn't super important, but I just wanted to show you those methods in case you see them in other contracts. All right, so that's almost everything for exceptions. One more thing to note here is that the only thing that will not be reverted if an exception occurs is low-level calls like this, addr.call. Now, I can't really show you what the other calls are because we haven't seen them, but essentially, if you were to send money to someone successfully, and then later on in the contract, there's an exception that occurs, that's not going to be reverted. You just can't revert that because once the funds are transferred, well, you can't really just transfer them back. And so if I did something like this, and let's say that this was successful, then that means this is not going to be reverted. Now, everything else will be reverted. This balances will be changed back, but this isn't going to be reverted. The Ethereum that was sent to that account is not going to be sent back to the smart contract. Okay, there's some good reasons for that, but that's worth noting. Now, a few other things to mention here with exceptions. Exceptions are cascading. Now that means if I have an exception that occurs in another smart contract that I'm calling from this smart contract, that's going to mean that the state of this contract, as well as the state of the other one, are going to be reverted. So it's kind of hard to show this, but let's say I make a contract and I call this my contract 2 like this, and let's just make some function. So we can do something like function test, and then just make this public view returns uint, okay? And then maybe what I do here is I just say revert, okay? So that's what I do. Now, if I call this function, okay, from inside of here, then even though it's happening inside of this contract, the exception's occurring here, it's going to cascade into this contract, meaning that if any of the state was changed inside of here, that's going to be reverted, and same with any of the state inside of my contract too. Hopefully that makes sense, but just keep in mind that exceptions cascade. So even if you have like 10 contracts all calling each other, and then in the 10th contract an exception occurs, every single one of the contracts that we're dealing with that contract are going to get the cascading exception, and all of them are going to have their state reverted and the transaction will fail. Now, just to note here, the reason why we're getting this error is because I didn't have the semicolon. Of course, revert is fine. I can put this here, although this doesn't really make much sense because why would you just revert inside of a function? All right, so now that we've talked about exceptions, what I can do is start showing you some new features in Solidity. And the first thing I want to do is show you a constructor. So I'm just going to clear everything that's inside of this contract, and I'm going to write a public variable here. So I'm going to say, let's go with address, and this is going to be public, and then I'm going to say that this is the owner of the contract. So what I'm going to show you is a constructor. Now, a constructor is simply a special function that's a part of a class, or in this case, a contract, that's going to be called when the contract is initialized. Now, in Solidity, your constructor will be called exactly one time, and just like any other language constructor, you can accept parameters in here, you can do some setup steps, and well, you'll see how this works. So the way you implement a constructor in this version of Solidity is constructor, open and close parenthesis, open and close curly brace, and then inside of here, you can do whatever you want. So in this case, I'm just going to say my owner is equal to the message.sender. Now, the reason I'm doing this is so that I can keep track of who actually created this contract. So when I create a contract, I have a message.sender, whoever sent the transaction to actually create the contract. So this is perfectly valid. I can say my owner is equal to the message.sender, and now whoever deployed the contract will be the owner, and I'll be keeping track of that inside of this public variable on the contract. Okay, pretty straightforward. That's how that works. Now, again, this is how you do the constructor. You can only have one of them, and this will be called exactly one time and only one time when the contract is deployed. This isn't going to be called every single time a transaction is sent to the contract. It's only called when it's deployed the very first time. So let me show you how this works. Let's go and actually deploy this to the JavaScript VM. Let's click on deploy. Okay, we have our contract. When I click on owner, it's going to give me the address of this account right here, which is the one that I'm using. Now let's try deploying from this account. Okay, so deploy, my contract's down here, owner, now it's giving me the other owner. Pretty straightforward. That is how the constructor works. And this is a pretty common thing that you'll want to do is keep track of who actually deployed the contract. Now, another thing that you can do in here is accept parameters. So maybe I just want to accept a uint, and let's just go with something like test for now. Again, this can really be anything. Okay, so I want this to be test. And then what I will do is say uint public, and let's just go with, I don't know, v. I'm just picking random names for now, and I can do something like v is equal to test. That's completely fine. I can access the value of this parameter. So now let's get rid of these contracts. All right, so now we can deploy our contract, and notice where the deploy button is, it's actually giving me a parameter that I need to pass here. It's saying test, this is a uint 256. So I'm going to do something like 2, hit transact. Now I go to my contract, I have owner and I have v, and I can see v is equal to 2. There you go. That is the basics of the constructor. Now, of course, you can have multiple arguments if you would like, or multiple parameters, and do whatever you please with them. Great. So what I'm going to do now is just get rid of everything inside of here, and I'm going to start talking to you about a new thing, which is called a pure function. Now, we've looked at view functions, we've looked at payable functions, internal functions, external functions, public functions. Now we want to look at pure. Now, a pure function is pretty straightforward, but it is simply a function that is not going to do anything with the state of the contract. You can kind of think of it like a static method because it has no access to the internal state of the contract. It just does some type of computations, then returns some value. So I'm just going to write a function here. I'm going to say function, and this will be something like add to. Now we will make this a public, and then this will be pure function, and this is going to return a uint like that. Now I'm going to take as a parameter here the uint x, and all I'm going to do is just return like this x plus 2. Okay, very straightforward, but this is a pure function. Now, as I said, a pure function is not going to modify or access the state of this contract. It's just going to be performing some type of computation that doesn't rely on the actual contract internal state. So just like accessing the data from a contract, this is going to be free as well. We don't need to pay to do this. And let me prove this to you. So if I go to my injected Web3 now, I'm connected to the Goerli test network, and I deploy this. Okay, it's going to ask me for a, I guess, transaction, because when I deploy, I need to pay for that. And then let's give this a second. Okay, we can see that our contract is deployed. Now let's do something like add to 5. Notice it gives me the value 7 back. I didn't need to add a transaction to be able to do this, okay? So whenever you have a view or a pure function, these are free. You don't need to have a transaction to call these. So if you ever just want some type of utility functions associated with your contract, then you make them pure. Okay, hopefully that makes sense. That's all I need to cover with pure. Okay, so now that we've gone through that, we can start getting into the important stuff, which is events. So I'm actually going to hop over to the drawing tablet to explain to you what events are, and then we'll start implementing them when we work on the auction. All right, so I'm now on my drawing tablet. I'm going to start explaining events to you, but before I can do that, I need to talk to you about why we need them. So in front of me, I have a smart contract. Now this is going to be our auction contract, and on the auction, we're going to have some function called start. Now, of course, we're going to have some other functions as well, but for now, just imagine we have start. And what start is going to do is it's going to attempt to start the auction. So it's going to modify some of the state, and then it's going to return a value indicating to us whether or not this was successful. So we're expecting this to be a bool. Let me just write this right here, indicating that's going to return a bool. Okay, that's great. So now we want to start the auction. So let's say we have some account. So account 1 like this. We know since this is going to modify state, we need to make a transaction to the auction to be able to start this. So I'm going to make a transaction. We're going to call start on here. And then what we're expecting is that we're going to get some return value here indicating to us whether or not this started successfully. Well, if we're just working on our JavaScript VM, then we know that this is actually going to work successfully. We're going to be able to get a return value. We'll see something like true, or we'll see something like false. However, if we're working on a real blockchain, we're actually not able to return something from a function that's modifying the state back to our account. So essentially, whenever we're making a transaction, we can't return data back to that transaction. Now, this actually makes sense if you look at how transactions work, but for now, you really need to understand that if you ever make a transaction to a smart contract, that contract cannot return you any data. Now, it can try, it can have a return statement, but you're not going to be able to view that return data from the transaction. So really, we have to imagine that this is going to be a one-way operation where we're just going to call start. Now, if an exception occurs, we're going to be notified of that. However, if an exception doesn't occur, we're not going to get any return value. So trying to do something like this is not going to work on a real blockchain. Now, that's a pretty big problem, right? Because in a lot of situations, when I make a call or I make a transaction, to my smart contract, I probably want to get a return value. I need some information. I want to know if this started successfully. However, we can't have a return value. So how do we get around this problem? Well, the way we get around this problem is with events. So what a smart contract can do is it can actually emit events. Now, that means that what we can do from auction is when we start this, we can create or emit something known as an event, and this event can have a return value that we might want this account to be able to see. So we can emit an event that says something like started, and then maybe we can put the time that this started at, and we can put if it happened successfully or not. So we can put true, or alternatively, we could put false. Now, these events will be stored on the blockchain. However, they're going to be stored in a different way than the data associated with your contract. So any of the variables you would have defined or kind of the state of the contract is said to be in storage. These events are not going to be in storage. They're going to be stored as a part of the transaction history on the blockchain. So that makes them a little bit less accessible. However, they are much cheaper to use because of the way that they're stored. So I'm not going to get into this too much, but essentially just understand that your events are stored in a different way that makes them much cheaper to actually store, although they are a little bit harder to access. So that means that you usually use a third-party tool, maybe something like Etherscan, to actually read and query these events because it's not as simple to go directly look at them like it is for the data on the contract. And so we emit this event, and then this account here, or some external client that's off the blockchain, is able to view these events and subscribe to them so they'll be notified if an event occurs. Now, I'm going to get into a detailed example in a second, but for now, just understand that whenever we have a transaction, our smart contract cannot return a value to that transaction. Instead, what it can do is emit an event. This event will be stored off the blockchain. You can kind of think of these events as a log, right? We'll be able to then view those logs off of the blockchain, and we can search for specific data inside of those logs and subscribe to events, which means we'll be notified when an event occurs. Now, just an important note here, this is not the case. So the no return value thing is not a case if we're making a call, not a transaction. Now, I understand this is a bit confusing, but if I'm making a call to a function that does not modify the state, so that doesn't require that I spend money on it, doesn't need a transaction, essentially, I'm just querying the state, then of course I can get a return value, right? If all I want to do is just get some data that's stored in the state of the auction, that's fine. I can do that. I can get a return value. But if I make a transaction that modifies the state, that's the situation where I can't get a return value. Okay, hopefully that makes sense, but that is why we need events. So now let me clear the screen and let's get into a more advanced example. All right, so for this example, what I want to do is imagine that we're trying to build an application that's going to be partly on the blockchain that's going to allow us to auction our NFT. So again, we still have this auction, this is our contract, but now what we probably want to do is we probably want to make a nice, beautiful user interface that allows users to interact with this auction. So to interact with the auction, the owner of the auction is going to need to start it. And then once it's started, we're going to be able to accept bids, right? Now the bid will be a certain amount of Ethereum, and we'll need to keep track of what the current bid is, who's currently winning the auction. We need to know when the auction ends, and all of that logic, again, will be handled by auction. However, we want a very easy way for users to be able to interact with the auction contract. I don't want them to have to write some really low-level code and send their own transactions. Instead, I want them to just be able to connect their blockchain account or their Ethereum account with my user interface and click this nice big button that says bid, okay? So they're going to be using my user interface. All of my clients are going to have a different instance of the user interface. Maybe this is something like a React app or something like a JavaScript client, whatever, right? So let's say we have kind of two user interfaces here, and we have two people that are bidding against each other just for simplicity. So I'm going to say that this is number one and this is number two. Now, the concept here is that this person's going to press the bid button. It's going to send a transaction to the auction. It's going to send maybe 1 Ethereum, and well, that's going to be their bid. And then this person, maybe they want to send a bid. Maybe they send a bid of 2 Ethereum. Now, this is all great, but again, we run into this problem where I want these user interfaces to be able to be updated whenever another bid occurs. So essentially, if I'm sitting right here, I want to know that number 2 just made a bid so that I can then bid again and I can bid 3 Ethereum, right? Now, how do I do that? Well, since I can't get a return value here, and since my auction can't send something to my user interface, it's not able to do that, what I need to do is use my events. So what's going to happen is every single time I make a bid, an event is going to be emitted. So I'm going to say emit, and then I'll emit an event that's going to be something like, let's write this properly, something like bid 1ETH, and then it will be from number 1. And then it will probably give the time that this bid occurred and a bunch of other information. But the idea is we're going to emit all of these events, and then what we can do is we can have these user interfaces subscribe to the events. So when they subscribe to the events, what's going to happen is they're going to be notified when an event occurs, and then they can use the data from the event to update their user interface and tell the user, hey, you just got outbid. Do you want to bid again? Or, hey, the current bid is this, or the auction ended, or whatever. You get the idea, but the concept here is we have an external client, right? So our JavaScript client's kind of sitting on some type of user interface. They are subscribed to the events that this contract is going to be emitting, and whenever the contract emits an event, they'll be able to update their user interface, and they could, say, query the state of the auction if they wanted to. They could do that for free because that doesn't require a transaction. Hopefully this makes sense, but that is the point of events, and this is kind of how you would start building out a very simple blockchain application. You would deploy your smart contract. This would be kind of your source of truth, right? This would handle all of the complex logic. Then you would have your nice user interfaces that allow the user to interact with the smart contract and be updated of things that's happening with the smart contract. Because the smart contract can only do some type of operation when a transaction is performed, so you need some type of external client sitting, listening for events, and updating the user. Then the user can trigger those transactions to the smart contract when they actually want to do something that is state changing. Perfect. There we go. We now understand the importance of events. Let's go ahead and go back to the computer. We're going to start writing out this auction contract and looking at events. All right, so I am back on my computer in Remix. We're actually just going to start working on the auction contract, and then as we work on that, I'll show you events. So I'm going to change the name of my contract here to auction because that's going to be a bit more fitting, and I'm going to implement a bunch of public things that we need here for our auction. So if we're thinking of an auction, we're going to have a time span for this auction. So we need to know if the auction has been started, if it's ended, how much time is left, so when the auction is actually going to end. We want to know all of the bids. We want to know who's selling the NFT. We want to know what the current highest bid is and who the current highest bidder is. And we also need to know what NFT we're selling, but we'll deal with the NFTs later because that's a little bit complicated. So for now, what I'm going to do is say address payable. It's important we do payable here because we're going to want to pay this person who you'll see is the seller. So we're going to say address payable public seller. Now it needs to be payable because, well, the seller of the NFT, we're going to have to pay the profits of the auction. So whoever, the highest bidder was, we're going to take money from them and send it to the seller. Okay, now other than that, we are going to need to know when the auction started. So actually, we don't need to know when it started. We just need to know when it's going to end, if it started, and then if it's ended. So I'm going to say bool, and then this will be public, and this will be started. We'll then say bool public ended, and we'll say bool, or sorry, not bool. This is going to be uint, and then this will be public, if we could spell this correctly, and then end at, and this will be the time that we actually are going to end the auction at. Now, other than that, we need the highest bidder. So we're going to say uint, or sorry, we want the highest bid. So I'm going to say uint public, and then this will be highest bid like that. And then we will have address. And do I want this to be payable? Let me look at my cheat sheet here. No, I don't think we need that to be payable. We'll just say address public, and then highest bidder like that. And that should be good. Now, other than that, we're going to need some mapping to keep track of all of the bids that users have made to this contract. So the idea here for the auction is that when you make a bid, you have to send money to the contract. So if you don't actually end up winning the NFT, then you need the ability to withdraw your money, right? So we're going to have a withdraw function that allows you, if you didn't win, to actually take all your money back from the contract. So I'm going to say mapping, and then this is going to be address, and this will go to a uint, and this will be a public, and then this will be bits. Now, the reason all of these are public is because I don't need to hide any of this information. It's fine if everybody sees it, and I want people to be able to see when it started, when it ended, what the end at is, what the highest bid is, because you want people to trust this contract. That's the whole point of writing smart contracts, right? Okay, so now that we have that, I'm going to make a constructor. I'm going to say constructor like this, and all I'm going to do is simply assign the seller. So I'm going to say the seller is equal to message dot, and then this will be sender. So whoever deployed the smart contract will be the seller of the contract. Now notice I'm getting an error here. It's going to tell me that the type address is not implicitly convertible to expected type address payable. Now, I didn't show this to you previously, but the way that you can convert a regular address to a payable address is you can just say payable like this, and then surround what you want to convert. So now this address that is not an address payable will be payable, and I'll put that inside of seller. Okay, now what I'm going to do is implement a start function. This function will allow only the seller of the NFT to start, and they'll need to pass all of the NFT details to be able to start the auction. Now, we won't implement the NFT stuff right now. As I mentioned, we'll do that at the end. So I'm going to say function. We'll just call this start. Then this will be public external. Okay, so we're going to call this from outside of the smart contract. And inside of here, what I want to do is I want to require that the message.sender is equal to the seller. Otherwise, I will say you did not start the auction, exclamation point, okay? And then we'll go with semicolon. Now, what's the error here? It says visibility already specified as public. Okay, so that's my bad. Sorry, I'm just going to make this external because you can't have public external. Those are going to be, messing with each other. So external is fine. Now, what's the warning? Function state mutability can be restricted to view. Okay, that's fine. We're going to change that later. Okay, so now what I'm going to do is I'm going to say started is equal to true. And then what I need to do is pick the end at date. Now, this is going to be a little bit weird because we haven't seen this yet, but I'm going to say end at is equal to, and this is going to be block dot, and then timestamp plus, and then 7 days. Now, we can actually change this so that it's not days. And in fact, let me check if that's correct. Okay, actually, I think 7 days is correct. So first of all, let's just explain what this line is because I haven't covered this. So block is actually referring to the block that this transaction is a part of once it's been mined, right? So once it's been mined, it will be a part of a block, and the block is going to have a timestamp. That's when the block was created. So this is going to give us the relative timestamp of the transaction. It's not going to be precisely when we sent it, but it will be very close to that because blocks are created very, very quickly in Ethereum. And then we're going to add 7 days to that. And days is a keyword just like Ether in Remix. So I can, or sorry, not in Remix, but in Solidity. So this way, we're just going to add 7 days to this timestamp, which means we will end 7 days after this. So of course, feel free to modify the number of days. I mean, you can make this 1 day if you want, 2 days, whatever. It doesn't really matter. In fact, let's just go with 2 days for now. But whatever you set this, that's going to be the amount of time the contract, the auction will last for. Okay, so now we have start. However, what I want to do is add one more require here that just makes it so we cannot start this contract if it's already started. So I'm going to say not started like that. And then I'll say already started exclamation point. And what I want to do is I want to emit an event saying that I started the contract. So now we're going to talk about how we actually implement events. Now, creating an event is actually pretty straightforward. You first need to declare an event in the body of your contract. So I'm going to do it up here. I'm going to say event and then start, and I've just created an event. Now we need to emit these events, but this is an event that is emittable. So what you do is you put the keyword event, you then put the name of the event. In this case, I'm going to go with start. Now notice I'm starting it with a capital because the convention here is Pascal case, just like our contracts. And then inside of the parentheses, you put any arguments you want the event to accept. So you could put, for example, the address of the person who started the event. Now that wouldn't really be very useful because the only person who can start the event, start the contract or start the auction is going to be the seller, but you could put any other data you want here. You don't need to put the time because that will automatically be associated with events whenever they're emitted, but I can put any data inside of the parentheses, and then I pass that data as arguments when I emit the event, and that'll be like the data of the event. We'll see this in a second. Right now for start, I don't need any arguments, so we won't look at that right now. But when I do events for a bid, I'm going to have the address of the person who bid, the amount that they bid, etc., right? Okay, so anyways, we have an event defined, which is start. And now if I want to emit an event, this is really straightforward. I just do emit, and then I put the name of the event like that. Okay, there you go. I'm now emitting the start event. Now, if start was accepting arguments, I would pass them right in here. So whatever the arguments are, right? Okay. There we go. Pretty straightforward. So now that we have that, let's deploy this contract. Let's deploy it to a legitimate network, right? So I'm going to deploy it to the Goerli test network, and then I'm actually going to go look at the events of my smart contract and show you how you can view them off the blockchain on Etherscan. So let's do this. I'm going to click deploy, and then once it's finished, I will let you know. Okay, so the contract has now been deployed. So I'm going to click on the contract deployment here. I'm going to view this on Etherscan. Notice it says that it was successful. So what I'm going to do now is click right on the contract. So notice it says contract here. It was created. So I'm going to click on that. And when I go here, we can see we have the hash of the transaction that created the contract. Then I can click on events. Now, when I go to event, notice we don't see any events. Now, that's because we haven't triggered any yet, but I'm now going to trigger an event and show you that it will show up right here. Okay, so let's go back to Remix. Let's now go to our contract, and let's start by just clicking on some of these so we can see the seller. Is it started? No, it's not started. So let's start it by clicking on start. Now, when we do this, of course, we need a transaction because this is going to modify the state. So I'm going to click on confirm. Okay, this is going to take a second to complete. And let's just go here, and it should tell us when this is done. Then we can go check the corresponding event that would have been emitted. Okay, so this is finished now. So let's go back here, and let's refresh the page. And notice that we have an event. Now the event is start, okay? And I can click on this right here and kind of view some of the details. Now the method will actually be the method that we called in the transaction. Now this is going to be a special hash of this method. I'm not really going to describe exactly how you kind of read this stuff because there is a special way to do that. However, whenever you're going to be subscribing to events or trying to get the data associated with an event, you're not just going to be reading it from this page. You're going to have a client. This client's going to be using a special library. A library could be something like Web3.js. This is a JavaScript library that kind of handles a lot of this complex lower level stuff for you, and it will kind of decode this data and tell you the stuff in the event. Now, I'm not going to show you how we subscribe to events in this tutorial because it's fairly complicated, but if you were writing, say, a JavaScript client or something, what you could do is use something like web3.js. So let's do this. This is the Ethereum JavaScript API, and inside of here, you can subscribe to events. So if we go to eth.subscribe, this is the thing right here. I'll leave a link to this in the description, and you can kind of view how you would do this and how you actually get the data associated with events from a smart contract. Okay, let's go back to Remix though, and let's continue. All right, so now that we've written the start method, let's write the end method or the end function. So I'm going to say function end external, and inside of here, I need to require a bunch of things. The first thing I'm going to require is that they started the contract. So I'm going to say require started because, well, if they haven't started it, they can't end it. So I'll say you need to start first, exclamation point. Doesn't really matter the error message that I give. Then I will also require that the block.timestamp is greater than or equal to end at, because I don't want to allow someone to end the auction if the end at time is not yet reached, right? Because that would be unfair. That means you could have someone like bid on it and then you could end it for them so that they would win it before anyone else was able to bid. Anyways, we're going to do this. We're going to say block.timestamp greater than or equal to end at. I'll say auction is still ongoing. Is ongoing one word or two word? I think it's one word. Someone can correct me in the comments. Clearly, programming is greater than spelling. Anyways, and then we also want to make sure that it's not already ended, right? So I'm going to say not ended. We'll say auction already ended. And let's spell already correctly. Okay. Exclamation point. Perfect. So now that we have all of our requires, what we can do is say ended is equal to true. And then we want to emit an event that says we ended it. Now, of course, when we end, we're going to actually have to transfer the NFT to the highest bidder. And then we're going to transfer the funds from the contract to the, the seller of the NFT. But for now, we'll just do the events. So let's go up here and let's say event and let's say end. Now for this event, I actually want to know what the highest bid was and who the highest bidder was. So I know who won the auction, right? So I'm going to say, let's go with address, and this will be, I guess, highest bidder. Okay. And then we will go with uint, and then this will be highest bid. Okay. So that's for event. And in fact, I guess I can do this. Yeah, that's fine. We can do that inside here. Okay. So now for end, I'm going to say emit and then end. And then inside of here, I'm going to pass the highest bidder. So let's go highest bidder like that. And then let's pass the highest bid. Perfect. Okay, there we go. Now, one thing I want to add to start is I just want to add a parameter here that's going to be the starting price or the starting bid or whatever for the auction. So I'm going to say uint, we'll say starting bid. And what I'm going to do is after I start this, or it doesn't really matter where I do this, but I'm going to say that the highest bid is equal to, and then this is going to be the starting bid. So this way you're going to have to bid at least a little bit higher than this to be able to actually win the item if you were, say, the only bidder. That way someone doesn't list this and kind of get screwed by only having someone bid like one way or two way or something and no one else actually bids on the NFT. Regardless, we'll have that for now, and we can now test if end is going to work, and then we can implement bid and we can implement withdraw, which are the other two functions that we're going to need. So let me save this. Now let's close this. I'm going to deploy the contract again. This will take a second. Once it's done, I will be back. All right, so the auction is now deployed. Now I can start this by passing, say, 1,000 way as the starting bid. We will wait for this to go through, and then we can try to end it. Now, I will show you that when we end it, this isn't going to work. Now, the reason it's not going to work is pretty obvious, but we don't have this condition being equal to true, right? The block.timestamp is not going to be greater than or equal to end at, so it's not going to let us end this, and I'll just show you that that works in a second once this starts. Okay, so that's started. Let's now go to this contract. The way I'm going to get to this is I'm going to open up MetaMask. I'm going to go to contract creation. Okay, let's go here. Let's view the contract. Okay, it's still indexing. Let me refresh this. Once it's done, I'll be right back. Okay, so now it is fully successful. Let me click on the contract. Let's go to events, and we can see that the event start has been triggered or been emitted, right? Because we started the contract. So now let's see what happens if we try to end it. So notice it's going to tell us that we're probably going to get a problem here. It's saying that gas estimation errored with the following message. See below, the transaction execution will likely fail. Do you want to force sending? And it's saying that the error's auction is still ongoing. So it's actually able to look at our smart contract and realize that we're not going to be able to do this because the block.timestamp is not greater than or equal to the end at time. So we can still send the transaction if we want. Now, if we do this, what's going to happen is it just going to fail? Now, when it fails and we hit a require statement, the require statement will return whatever remaining gas we had as a part of this transaction back to us. However, some gas is going to be lost. Now, that's one thing to note here with require. It does actually return your gas if this fails. Again, not all of it because it still had to use some gas, but it will return whatever wasn't used. So you can see here we're getting this error, right? It's telling us this didn't work, and we weren't able to do that because this require statement would have been, well, not true, right? It would have, caused an exception. Okay, so hopefully that makes sense. That is how that works. Now that we've done that, let's start implementing the bid and the withdraw functions that we need. Okay, so let's code out the bid function. Let's go with function bid external. Now this needs to be payable because this is actually going to accept Ethereum, right? So inside of here, we need to require a few things. We're going to require that we have started the auction. If we haven't started, then obviously we can't do this. So I'm going to say not started. We're going to require that the block.timestamp, again, this is a global keyword that we have access to, is going to be less than the end at time. So this means that the contract is not ended, or sorry, I keep saying contract, I mean auction. So we'll say ended, exclamation point. And then we will also require that the message.value, so this is going to be the value of the bid because they're going to be sending the amount of the bid, right, is greater than, and then this will be the current highest bid. Okay, so now we have all of our require statements. Now let's see why it's getting mad at us here. It's saying expected semicolon, but got identifier. Okay, I need a semicolon right there. So now if this is the case, what we're going to do is we're going to update the amount of money that people have sent to this contract, kind of similar to the bank account by using this bids mapping. And we're going to update the highest bid and the highest bidder because at this point we know this person would have bid an amount higher than the highest bid. So we need to update those values, right? So we're going to say that the highest bid is equal to message.value. And we're going to say that the highest bidder is equal to the message.sender. Okay, so now after updating this, since the highest bidder has now changed, what I need to do is make it so the person who just got outbid is able to withdraw their money from the contract. So I'm going to say if, and then this is going to be the highest bidder. So not bid, but bidder does not equal the address 0. Now, address 0 is the default address. I'll talk about this in a second. Then what I'm going to do is say that bids at, and this is going to be highest bidder plus equals, and then the highest bid. So the logic here, why is this yelling at me? Let's see what the problem is. Operator not compatible with types uint 256 and address. Sorry, this needs to be highest bid, not highest bidder. Okay, that's better. But the logic here is that as soon as someone gets outbid, I want to allow them to withdraw their money from the contract so that they could withdraw and then bid again, right? Because otherwise they would need to have a ton of Ethereum to be able to actually continually outbidding someone if all of their money is stored in the contract. So hopefully this makes sense, but since we're updating the highest bidder now, if the highest bidder was not equal to address 0, so essentially if this was not the first person to make a bid, then what we do is we take whatever the highest bidder was, store that in our bids mapping, and then we add whatever their highest bid to that so that now they're able to withdraw. And let's say they don't withdraw and they just continue making bids. That's fine. This will continue to increment however many bids they've made. So then they will be able to withdraw all of that if they're not currently the highest bidder. Okay. And actually they'll be able to withdraw whatever amount inside of there is not their current bid that's being stored in highest bid. You can look through this logic and probably see why that makes sense. But address 0, just to clarify, here is the default address. So when I write something like address public, for right now, sorry, not address public, but address public highest bidder, it's going to be storing just a 0 filled address. So I'm just making sure that it's not equal to the 0 filled address. And you can do that by just writing address and then putting 0 inside of here. Okay, so that is bid. That's pretty much all we need for bid. Now we want to write the withdraw function. So I'm going to say function withdraw like that. And then this is going to be an external payable as well. And inside of here, what we need to do is withdraw a certain amount, or I guess we'll just withdraw the entire amount of whatever the person's bidded that's not the current bid. So we're just going to start by getting the amount of money they've sent to this contract that's not currently the highest bid. So I'm going to say a uint, and I guess I'll just go with something like balance is going to be equal to, and then this will be bids at message.sender. And then what I'm going to do is say bids at message.sender is equal to 0, just to reset that. And then I'm going to send whatever their balance is to them. So the way I'm going to do this is I'm going to write this complex line. In fact, I'm just going to copy this in because we saw this in the last video. I'm going to say bool sent bytes memory data is equal to payable message.sender. So just converting that address to a payable address dot call value. And then this is going to be balance. Balance is right here, right? And then what I need to do is require that this was successful. So I'm going to say require sent, and I'm going to say could not withdraw. So let's do this. Could not withdraw. Let's add our semicolon, and there we go. We have just implemented the withdraw function. Now, what I'm going to do is actually add some events here as well for bid and for withdraw. Then we can test this out, and then we'll start actually working with an NFT because right now we're not really auctioning anything. So let's make some events. Let's make an event for bid. Now, what I want to do is have an address. Now, this is going to be indexed. Now, we haven't seen this keyword before, but what you're allowed to do whenever you're defining the arguments for your events is you can put an indexed parameter, and you can actually put up to 3 of these, and this is what you will be able to search for an event for. So if I say indexed here, then this means I can search by whatever this parameter is for this event in my logs, right, or in my events. So I'm going to say address indexed. Let me just look at my cheat sheet to make sure I don't mess this up. It's going to be sender, and then we're going to say uint amount to specify how much they actually bid. And then we'll do an event, and this is going to be withdraw. And this again will be an address that's going to be indexed. This will be the bidder, and then this will be uint and the amount that they withdrew. Okay. I think that is fine. Now, what's it telling me? What's it saying I did wrong here? Oh, I spelled index incorrectly. Okay. So let's go and let's now emit these events. So I'm going to say emit, and then this is going to be bid, and then we're going to pass to this just the highest bidder and the highest bid. Okay, perfect. Let's add our semicolon, and then for withdraw, we will say emit, and then withdraw, and then we're going to emit the message.sender and the balance. Great, there we go. Okay, so now let's actually just deploy this. We can do some experiments with it. I'll set up another Ethereum account, make sure it works, and then we'll talk about the NFTs. So I'm going to deploy. Once it's done, I will be right back. Okay, so I am back. This finished deploying. My contract is here. I actually started the contract with a minimum bid of 1,000 Wei. And now what I'm going to do is change my Ethereum account. In fact, I've actually already done this. So I deployed this contract from my tutorial account, but now I'm on account 1. So now I'm going to make a bid from account 1 and show you how this works. So I'm on account 1. You can see I've reconnected this here to, Remix. And now I'm going to make a bid of 1,000 Wei. I'm going to click on bid. Then when I do this, notice it's going to tell me that I'm probably going to get an error. The reason I'm going to get an error is because this is not greater than the starting bid. And so I'm just going to cancel the transaction. So I'm going to change this now to be 1,001. Let's click on bid. And let's see, okay. So confirm. Let's give this a second. And again, notice I'm not going to get any return value here. It's not going to tell me if this was successful or whatever. I'm just going to see that the transaction didn't fail whenever this is done. And then I should see an event be emitted here. Okay, so let's now refresh this. And we now see, okay, maybe we need to wait a second. Okay, so the event has showed up. I just had to wait a second. I was being impatient, but after I refreshed a few times, it appeared here. Anyways, this has happened successfully. I know this looks like gibberish, but if you were actually subscribing to this event, then you would have some library that would be translating this for you, so you'd be able to read the real data. Regardless, the bid happened, and I can look now at, for example, the highest bid, which I can see is 1,001, the highest bidder, which is this address. I can look at the seller, which is different, if the contract is started, and all of this type of stuff. Now, that's pretty much all I wanted to show you for that. Since we don't really have 2 days to wait here for this to finish, I can't show you it actually ending. What I will do, though, is I will now start implementing the NFT stuff, which is a little bit complicated, but it's pretty cool, so I'll try my best to explain it to you. All right, so I've just switched tabs, and I'm going to try to explain to you the difference between fungible and non-fungible tokens and how these kind of live on the Ethereum network. So I'm sure all of you are familiar with cryptocurrencies, right? We have currencies like Ethereum, we have currencies like Bitcoin, and we have a ton of other currencies that are built on top of these main blockchain networks. So if we're talking about coins that are built on Ethereum, these are tokens. Now, really all a token is a smart contract that defines that your address owns a certain amount of tokens. Now, this is specific to Ethereum, but if you're working with a token that's on the Ethereum network, really what gives you the ability to own that token is that there's a smart contract with the name of that token. It's named, say, TimCoin, for example, right? If I had my own token on Ethereum, and in that contract, it says that your address has 20 TimCoins or 100 TimCoins or whatever it is. Now, the way this all gets standardized is that what happens is you need to implement specific methods or specific functions on your smart contracts that make it act like an ERC20 or an ERC721 token. Now, ERC20 is simply a protocol for a specific token. In this case, it's a fungible token. Now, ERC20 states that you need to define some special methods on the smart contract. Now, if you do that, Ethereum is able to look at your smart contract and treat that smart contract like a token rather than just any other smart contract. Now, that means in your Ethereum wallet, you're going to see your tokens showing up, or you'll be able to link them. You'll be able to then say buy these tokens or exchange these tokens because you've defined certain functions on the token and it meets the ERC20 protocol. Hopefully that makes sense. Now, ERC20 is simply a fungible token protocol. What that means is every single one of these tokens is exactly the same. So there's no difference in you owning one of the tokens or the other tokens. Like any token is just identical. Each of them has the same value. And as it says here, this makes ERC20 tokens useful for things like medium of exchange, voting rights, staking, whatever. Okay, that's what you can use these tokens for. However, now we go over to ERC721. Now, ERC721 is fungible tokens. Now, fungible tokens mean that these tokens are different. So there could be a different value associated with each token. Maybe there's some assets like an image associated with a token, hence NFTs, right? Maybe you get some special rights with a specific token. Tokens are unique, they are different, and they have a unique ID. Now, this is very similar to ERC20, except you're just having these unique tokens and you have some special functions now that you need to define on smart contracts that are defining an ERC721 token. So it's a little bit too complicated for me to show you exactly how to create your own NFTs or your own ERC20 tokens, but the concept is, again, that we have this smart contract. This is an example of an NFT contract. This smart contract defines who owns what NFTs. It's capable of creating new NFTs. And then if I wanted to say, send my NFT from me to you, what I would do is call a function on the smart contract that transfers the NFT. I have to be the owner of the NFT to be able to do that. And then it changes the internal state of the NFT contract to now define that you own my NFT because I sent it to you. So hopefully this makes a tiny bit of sense, but that's the general idea behind tokens and behind NFTs and all of this type of stuff. Now, as you can see here, there's some other types of tokens that you can create, but ERC 721 is the one we're going to work with right now. And what we're actually going to accept in our smart contract that's going to be the auction is the address of a smart contract that represents an NFT, as well as the unique ID associated with the NFT that the user wants to auction. So whenever you get an NFT, it has a unique ID associated with it because every single ERC 721 token is unique. When I say ERC 721, that really just means non-fungible token, okay? And so it has a unique ID. If I pass that unique ID along with the contract representing that NFT, then what I'm able to do is verify that the user owns that NFT and then actually list it in the auction and transfer it between different people. Okay, so now let's get into some even more complicated stuff because I need to show you how we can make our own NFT. And when I say make our own NFT, I'm not talking about make your own NFT contract. I'm saying kind of acquire an NFT in your Ethereum account so that you can follow along and actually auction off your own NFT in this tutorial. All right, so to do this, I'm going to go up to this other tab here where I have token.sol. Now, I'm not going to explain any of this code, but essentially this is my own TimCoin NFT, okay? And I'm going to give you guys all the privilege of owning some TimCoin completely for free. It has zero value and it's going to be on an Ethereum test network, but you can own it for free. You are welcome. And the way I'm going to do that is I'm going to deploy this smart contract. I'm going to leave a link to the contract address in the description, and you actually are able to create your own NFT by calling this award item function, which is going to give you your Ethereum address, a NFT, okay? It's going to give you a special ID essentially of TimCoin. I'll explain this more in depth and I'll show you exactly how to do this. But right now, when you're watching this video, this will be deployed on the Goerli test network. So you need to make sure you're using that test network. And then what you'll be able to do is interact with this contract from Remix. Again, I'm going to show you exactly how to do that. It will then award you an NFT. And then once you have that NFT, you'll be able to auction that NFT inside of our test contract. Now, before I show you how to do that, we're going to implement kind of the NFT logic in our contract. Then I'll show you how you get your own TimCoin NFT. Again, you're welcome. You guys can thank me in the comments. Okay, so what we're going to do is we're going to now specify what's known as an interface that we are going to accept for a specific contract, which is going to be the contract address of the NFT that we want to list. So I'm going to say interface. So actually, there's not a ton of value of me typing this in. So I'm just going to paste in the interface and I'll explain what this is. So first of all, an interface is an abstract data type. The reason we're going to use an interface is because we need to verify that the contract passed to this auction does actually represent an NFT. And so we're going to treat the contract as an IRC 721 type contract, which means we're going to make sure it has a transfer and a transfer from function on it. Now, if you're unfamiliar with interfaces, I can't explain them too much in depth. Essentially, they just enforce that anything that is of type of this interface has these methods that are specified in this way. So for us to have a valid NFT contract, really all we care about is that it has a transfer and a transfer from function that we can use. Now, the transfer from allows us to transfer from one address to another address, a specific, NFT ID, okay? So as I was saying before, all we're doing is we're going to be calling a function on the NFT contract that takes in the address of the owner of the NFT, the address of the receiver of the NFT ID. It verifies we own this NFT, and then it would transfer it to here. And then transfer is simply going to take an NFT ID and transfer it to a specific address once it's been approved to do that. You'll see what I mean in a second, but anyways, that's our interface. So what we're going to do now is we're going to go inside of our auction, and we're going to define the NFT that we're actually going to be auctioning. So I'm going to say ERC 721 public, like this, NFT. And then what I'm going to do is I'm going to say uint public NFT ID, okay? So what I'm saying is I want to store the contract of the NFT address here. It's going to be of type IERC 721, meaning it has to have these functions on it. And then I'm going to have uint public, not NDT, NFT ID, which is going to be the unique ID of the NFT that we want to auction. So now inside of my start function, what I'm going to do is take in a starting bid. I'm going to take in the NFT contract and the unique ID of that NFT. So I'm going to say IRC 721. This is going to be NFT, and we'll make this underscore NFT. and then we are going to say uint NFT ID. We'll just make this underscore again so it doesn't mirror our global name, and then comma. Now let me make sure I typed that correctly. I think I did. Okay. So now inside of here, what we're going to do is we're going to set the NFT. So we're going to say NFT is equal to, and then this is going to be underscore NFT. Again, this is the contract representing the NFT. Then we're going to say NFT ID is equal to underscore NFT ID like that. Now, what I'm going to do is just take these two lines here and put them after I do this, just in case these return some error, although it doesn't really matter because if an error was returned, then the state would have been reverted, but that's fine. Okay, so we're going to do that. Now, what we also need to do is we need to transfer this NFT from the owner of the NFT to this contract. So now the contract owns the NFT and then is able to actually transfer this to whoever wins the NFT in the auction, right? So what I'm going to do is say NFT dot transfer from, and we're going to transfer from, and this is going to be the message dot sender, who we're assuming owns the NFT, to this, or sorry, it's going to be address this like that, and then this is going to be NFT ID. Okay, so this here is going to fail if we don't own the NFT. So if whoever called this start here doesn't own the NFT, then we're not going to allow them to transfer because the NFT contract will raise an exception, and so that whole thing will cascade, meaning all of this is going to fail as well, and so we won't actually start the auction. So we're only able to start the auction if we own the NFT and if we have the ability to send the NFT from the sender to this address, okay? Hopefully that makes sense. I'll explain again how we kind of set the NFT up and how we actually make an NFT and get access to it in a second. So now that we have that, what we need to do is deal with what happens when the auction ends, because once the auction ends, we need to send the NFT to whoever won it, and then we need to take the balance of the contract and specifically whatever the highest bid was and send that actually to ourselves, right, to the seller of the NFT. So all we're going to do here is we're going to check if the, and this is going to be highest bidder, does not equal the address 0. Because if it's equal to the address 0, that means no one actually bid on this item. And so we can just return the funds or return the NFT to ourselves. So anyways, we're going to say if this is the case, then that means that we're going to take whatever the highest bidder amount was, or the highest bid, sorry. We're going to transfer that to ourselves. And then we are going to transfer the NFT to whoever won the NFT. So I'm going to say NFT dot transfer. And then we're going to transfer it to the highest bidder. I think that's all I need to put in here. Let me confirm that's correct. Oh, one more thing, the NFT ID. Okay. So we're using the NFT contract. We're using .transfer. We're going to transfer it to the highest bidder. And then this will be the NFT ID. Now, what it's saying is the issue. It says transfer is not found. Well, that's because I spelled transfer incorrectly. Okay, that's fine. Then after that, we're going to figure out whatever the highest bid was, and we are going to then pay that to ourselves, the seller of the NFT. So the way we do that is we just copy in this line because I really don't feel like writing it again. So we're going to say bool sent, and then bytes memory equals data, seller.call value, and then this is going to be highest bid, and then we'll call that like that. And then we're going to require sent, and we're going to say could not pay the seller. Okay. There we go. Now in the other situation, so if the highest bid actually is equal to address 0, then what we're going to do is just return the NFT to ourselves. So we're going to say NFT dot transfer, and then this is going to be to, I guess we will just say the seller, and then this will be NFT ID. And I think that's it. Again, I spelled transfer incorrectly. Let me just make sure that's right. Looks good to me. Awesome. Okay, so that is actually all we need for this contract. Now, this contract should work. However, I need to show you how we can now actually get access to an NFT and what that looks like in our account. So I'm going to start by deploying this contract. Now, be careful what account you deploy this from. I'm going to deploy it from this one. So I'm going to deploy test.sol, which is really just my kind of auction contract. Let's confirm this. Okay, this will take a second. Once that's done, I will be right back. Okay, so that has now been deployed. Now remember, to be able to start this auction, we actually need the address of our NFT. So I am now going to deploy this NFT contract here. I'll leave the link to it in the description, or you could just painfully write out whatever the number of characters are. But again, it'll be linked in the description, and I'll show you how you can use this to get your own NFT. So let me now deploy this. I need to pass a string name and a symbol. Actually, do I need to do that? Oh, sorry, I'm doing the wrong thing. Okay, let's deploy TimCoin. So I'm going to deploy TimCoin to the Goerli test network. This is going to take a second, and then I will show you again how we can actually access this and get our own NFT. Okay, so TimCoin has now been deployed. Now for me, I can see TimCoin right here, right? And we see all these different methods. You don't have to worry about a bunch of them. But anyways, you're not going to see this inside of your remix because you didn't deploy this contract. But you need to interact with the contract, again, on the Goerli test network. You need to be on the Goerli test network, otherwise this isn't going to work for you. So what you're going to do is you're going to take the contract address, which will be linked in the description, and you're going to paste it right here where it says or at address, okay? So it should say that right at the bottom. You're going to do that, and then it will load this contract. Now notice it just loaded the same contract for me twice because I already had it here. But that's how you can load it. Again, just copy it, paste it in here, and then it will load it right here. Now, what you're going to want to do is you're going to want to start by setting the approval for all. Now, I'm going to discuss what this is in a second, but essentially what you need to do here is you need to allow this smart contract, being the auction, to actually transfer your NFT. Now, if you don't allow it to do that, you're not going to be able to actually auction the NFT. The reason you can't auction the NFT is because the contract will not have the ability to take the NFT and transfer it to itself. So you have to explicitly give the contract permission to do that before you create your NFT. So what you're going to do is go to your auction contract. This is going to be different than mine. You're going to copy the address of your auction contract. Okay, I've done that. I'm going to go to TimCoin. I'm going to go to set approved for all. I'm going to paste in my contract like this. And then I'm going to go comma, and I'm going to go true. Now, look here, it says operator, which is this. So the operator is the auction contract. It's going to be operating on this NFT, and then true. Now, what this is going to do is it's going to allow this contract to pretty much list any of your NFTs. Now, you still have to call the contract for it to do that, but you're giving it explicit permission for it to access any of the TimCoin NFTs that you have access to. So don't worry, this doesn't mess with any other NFTs you might have on your Ethereum account. And we're on a test network anyway, so it shouldn't matter. But I'm going to press transact. This should go, or this should be successful once I click confirm here. Okay, so let's wait for that to finish. And then we have set the approval for all of the NFTs that you own to be able to be operated by the auction contract. Again, what you're passing here is the auction contract. Now, it's very important that you do this first before you actually give yourself an NFT. Otherwise, the NFT you give yourself will not have the approval set for it for the auction contract. Okay, so now that we've done that, let's close all of these. And we're going to go to the award item function. Now, this is what you want to press when you want to give yourself an NFT. So you're going to copy your address. So my address is right here. I'm going to copy it in to award item. And then what it says here is that there is a URI. Now, the token URI is actually a URL to JSON metadata related to this NFT. So as you may have seen, NFTs have like fancy images and music and GIFs and all of this very valuable stuff. Anyways, the point is, all of that stuff is stored off of the blockchain on a specific URL in JSON data. And so what you actually have to do is associate data with your NFT off the blockchain. So when I create the NFT, I pass the URL of the data sitting off the blockchain that represents my NFT, and then it links those two together. And that's why when you go and you view NFTs, you see like a nice little fancy image. It's because it's referencing the URI of this NFT, and then it's grabbing the image for it and displaying it. Pretty straightforward, but that's really how NFTs work. Again, it's not meant to be an entire lesson on NFTs, but the token URI is just that, it's a URL. Now, you actually don't need to pass anything here. I'm just going to pass like 1, 2. Like, you have to give some data, but you don't have to give a URL. So I can pass 1, 2, 3, 0, whatever, doesn't matter. So just go like that. And when I hit transact, then what's going to happen is it's actually going to give your Ethereum account or whatever account you put the address for an NFT. So let's wait a second. And then I'll show you that we actually will have TimCoin showing up in our Ethereum wallet. Okay, so that finished. So now if I go to MetaMask, so let's get out of this here. Let's go to MetaMask and let's look at my account. let's go to assets, and notice how it says, don't see your tokens, import tokens. So I'm going to click on import tokens, and I'm going to copy in the token contract address of TimCoin. Now, again, that's what will be linked in the description. I can just copy it from right here. So I'm going to go here, going to go to assets, import tokens. I'm going to paste this in. Notice the symbol is Tim, very fitting. For the token decimal, just put 0 and then add custom token. And now it's showing that I have one Tim token. So I'm going to go import tokens like that. And now if I look at my assets, I see one TimCoin, okay? It's just looking at the contract, and since it follows the ERC 721 protocol, it's able to specify that I have one of these. Now, if you want to own multiple, just do this again. Just call the contract. You can even pass the same URI. It really doesn't matter. And hit transact. And now when you do this, you're just going to have to wait a second, and then your wallet should update. And once this is done, you'll now have 2 TimCoins. And in fact, just because this is interesting, I will show you that if I go to MetaMask, I go to my wallet here, and let's go view account on Etherscan, you can actually view the TimCoins that you have on here. So notice I can go to token, and I can specify TimCoin. And when I go here, you can see that I have the token ID of 1. I have 1 TimCoin that was just added here in 1 minute. Now, if I refresh this, I should have a second TimCoin in a second because I just requested that. Okay, it might take a second. So let's go back to where we were before. Okay, award item, let's refresh. Okay, so now we should have 2 TimCoins. If we go here, yes, there we go. Now we have TimCoins, and the token ID is 1 and 2. So if you want to see what your token ID is, because all of you are going to have a different token ID, you need to do what I just did. Go to MetaMask. You're going to view your account on MetaMask. So I went to, where is that? Here, view account on, sorry, not MetaMask, on Etherscan. It's going to bring you to Etherscan. And then what you can do is go to your TimCoins. I showed you how to do that, but let's go back. So you're just going to click here, click on TimCoin, and then it will show you your token ID. So you own token ID 1 and 2. Well, in this case, I own 1 and 2. You'll own something that's not 1 and 2 because it's going to be a unique ID. So this means I can auction token ID 1 and 2 because I own that. So now how do we auction it? Well, this is kind of the moment of truth here to see if this is all going to work. So I'm going to copy the address of my TimCoin NFT contract, okay? Then I'm going to go to start. I'm going to paste that in as the first argument. So let's go here. For the NFT ID, you have to post an ID that you own. So either 1 or 2 for me, and then put a starting bid. So I'm going to put 1,000, and I'm going to hit transact like this. Okay, fingers crossed. Once I hit this, let's see if this works and if everything we did was successful. Okay, so very good. We see the green check mark here, meaning that this was good. So now let's go to NFT and notice the address is this. NFT ID is 1, seller is me, started is true, highest bid is the 0 address because no one's made a bid yet, and then we have highest bid. Now, of course, this will work as it would work before as we tested it previously, and this will now take, how many days did we set? If we go here, I think we set 2 days. Yeah, so after 2 days, then you'll actually be able to win your NFT when someone hits the end button or sends the end request to this contract. Okay, so that is going to wrap up the video. I hope this was helpful in terms of giving you a deeper understanding of Solidity and smart contracts and showing you a real practical application hosted on the blockchain. Now, in the next videos, we're going to be talking about some of the scaling limitations of Ethereum and of Solidity and some of the problems you can run into when you need to perform large computations. Then I'm going to be showing you some scaling solutions, so ways that you can mitigate those concerns. And we'll be talking about Cartesi, which again is the sponsor of this video and this series, and showing you some of the solutions that they provide. Again, I really hope that you guys have learned a lot from these videos. I've been having a great time filming them, and I look forward to posting more on the channel. With that said, if you enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in the next one.